So I think we can read the material for this project. So this that's the paper I mentioned. I sent it to you already. So this is a literature review. So literature review is like they summarize all the current technology used for wearable technology in healthcare. So this is a very good paper. So you no need to read lots of papers. So they already read for you. So they summarize all the direction and also the applications and the future directions. So survey paper is very important. Like it's just literature review. You actually before they ask a student to write literature review, but we remove this part. But I still think this is a good. Why we this give you a reason why we need this learn this technology. You can see so many applications for identification and prevention. We will discuss. Lee will give a demonstration. Yeah. So everyone, if you have any questions, you can just stop me anytime. And because we are small class, we are very free. So we are very I mean we in a relaxed uh, teaching mode. So everyone, welcome to stop me. Uh, so you can see this physical activity interaction monitoring and the mental status monitoring. Status monitor. This morning I listened to the ABC uh, broadcast. They said that due to the coronavirus, the suicide rate is increasing. So the government want to put some funding to support um, people with some to keep mental health. So the mental status monitoring is also we can use a wearable device. So wearable device is a very broad area. For example, you can use wearable um ECG, wearable EMG and EEG machine. Is also called I mean wearable device. So there's also sports medicine. Of course, I maybe someone already use this one when doing sports. You have see someone put a mobile phone uh, on the arm, and when do the exercise, they monitor their exercise rate and the things, and also weight control and monitoring, and also public education. So today we use this one as a education tools, and also cancer survivors monitoring, and especially nowadays the telehealth, just like if someone at home, for example, coronavirus, especially for old person at home, can you develop a wearable device to implement telehealth? That means the person can no need to go to the hospital because they have a coronavirus. Uh, so they only stay at home and then send the information, for example, the heart rate, the breath rate, and uh, their for example, the EEG signal to the doctor. The doctor can monitor, and also heart disorders. You can detect I mean heart problem. For example, you can measure, you can monitor the heart rate variation to identify the heart problem, and the blood, for example, you have some is wearable blood pressure measurement as well, and so they have diabetes care management and Parkinson. So before we develop the use IMU, try to detect, predict, both use IMU and use EEG to predict the frozen, because you know the Parkinson disease, the most difficult for patient is like they frozen. When they frozen, they feel very pain and very difficult. And then we developed the EEG based uh, EEG based technique, and we can predict the frozen, and then we can use music to let him to get rid of the frozen, and also autism. Autism is kind of very recently is very common in the young student, and also depression, also the things. And we look at the one I find like is here. I summarize here because we use this. So I'm summarized here. So this is fall detection. We can read the even read the video. So I put the video and then there's lots of video. I randomly select the first video.
Hi, this is a demonstration of fall detection application. I am launching the application now. Before starting the fall monitoring, let me go ahead and configure some alerts.
Li Wang will also give
Let's have a
Li
waiting
will also
duration of
give
5
an
seconds.
example. So
Let's
I'm not
choose
play
to
long.
have the audible alert, and let's have a bell duration of 5 seconds as well. And let's choose some sound to play. Let's configure email alerts. We are including our location as well as a list of hospitals in the vicinity. Let's
So this is a very popular tools. So, but we not go too far. And because we have another very important thing is called physical activity interaction. So this one we actually talking about use in the hospital.
Caregivers can have a new
Is a
way to keep a closer watch on patients on general
Philip
care floors
product.
and in ED waiting areas in need of more frequent monitoring, using wearable biosensor technology from Philips. Worn on the chest, this discreet, lightweight biosensor provides the ability to wirelessly monitor vital signs, posture, activity, and detect falls automatically and frequently. The single patient use biosensor offers a broad range of continuous measurements, while giving patients enhanced comfort and mobility. Patient data is sent to the Philips IntelliView Guardian solution, which analyzes the combined trend of the measurements and updates the patient's EMR. For hospitals feeling the strain of limited staff, the wearable biosensor and IntelliView Guardian solution provide your nurses peace of mind in the hours that pass between spot checks.
So this is another I mean the case I mean the possible application. So we look at the next sports medicine. Sports medicine is also a very popular area. Is
Neurological impairment from accidents, stroke, Parkinson's, and other diseases. For many, the effects include difficulty walking. Professor Masayoshi Tamazuka and his team at UC Berkeley are trying to help.
We are working on a National Science Foundation project that focuses on the design of a wireless human motion monitoring system for gait rehabilitation and physical therapy.
Dr. Tamazuka and team have developed a prototype system, including several sensors, to provide visual feedback to patients and therapists.
We believe the system will help the physical therapist with disease diagnosis and help the patients better understand their walking abnormalities.
The first sensing device is called Smart Shoes, initially developed by Dr. Kumchur Kong, who together with Dr. Jumbam Bai showed its potential for use in rehabilitation. The shoes have been refined and made wireless by Wenlong Zhang. Four barometric
so this is another things used for sports medicine or even for patient monitoring. So we can analyze the gait of the person. For example, when you do fall detection, it's easier. But if you want to do fall prevention, it's a little hard. Because fall detection is like when fall happened, you need to detect that this happened. But if you want to predict, you want to prevention, you need to predict. Because for older people, when they develop the I mean unbalance is have a procedure. They gradually developed. So can you based on the gait analysis, that means they are when they walking, can you see their balance? If the balance is very good, and then the possibility for falling down is very low. But when they start to change their their gait, the balance become worse, and then they are more likely to have falling. So we need to tell them and to be careful, and even maybe let them to use wheelchair. So and also let them to do exercise to make the walking balance. So this is a I have seen the video, and then they developed some sensor under the put it on the shoes, and then they can measure. I mean, they can analyze the gait. Actually, we use several MU. It's also possible. So actually, we have a project. Is a cross faculty project with the Faculty of Science, Faculty of Health. We just use the uh, uh, e- initial measurement unit. Actually, Li Wang is involved in the project. He developed AMU, a small AMU, can put on the pregnant woman during the pregnant, and then we can monitor the movement of the pregnant woman, and then we can uh, um, get some more understanding. Of course, we use other sensors as well. We use, for example, millimeter wave to localize the person as well. But anyway, so this is a very good area. In the future, there's a big opportunity uh, for for your career. So that's why I hope you can stay with me and to learn it very carefully, and to some technology maybe you can directly use to contribute to this area. So this other part I don't want to go too deep. For example, I only mentioned about one is the mental status monitoring, or I already mentioned. Another is the rehabilitation and assistive device. So like a future, if you select this studio, in the senior studio, you will learn some assistive device. Actually, the wearable device provide all the sensor and actuator for the rehabilitation and assistive device. So currently we develop artificial hand. I think Lee is also involved in, and we use IMU as well to sensing the movement of the hand and give feedback. Uh, so this is a very important area for application as well. And in the future, is maybe the prediction is like new devices, like because wearable device now is, I think because of the wearable technologies growing very fast, so we can see more sophisticated equipment will appear, devices will appear, and also for the AI technology, the AI now is very popular. Like when you find a job, or you want to publish a paper, or you want to apply funding, if you without artificial intelligence, it's quite hard. The wearable device is a contributor to AI. The AI is nowadays is a deep learning or something, but they need big data. But wearable technology and IoT, Internet of Things, they provide enough data, personal data. They can do analysis, use AI technology. So that's why in this subject, in this studio, I also in the last week, I will discuss about uh, machine learning or artificial intelligence. Like if you use MATLAB, MATLAB have a very powerful tools. They provide called classification learner. There's a Ansible app. You can use that to quickly use, but you cannot get the deep understanding, but you can know how to use it. We will show you later. And they also have the deep learning toolbox. If in the future, if you want to be a researcher, or you want to work in a company as a manager and things, you need to understand like most current technology, like artificial intelligence. Um, Now I start to introduce the projects. So we have three projects. These three projects are all related uh, with a smartphone-based body movement. So the first one is fall detection. So as we discussed already, uh, but Lee will give a demonstration for the fall detection. Before the demonstration, I show you what I prepared for the requirements of project. So the first one is smartphone-based fall detection and alarm system. So this one, I mean, uh, This is a description and the potential application and objects, objectives. So the main issue is the general procedure you need to understand. The first, you need to collect the signals, like acceleration signal, or the angular velocity signal measured by gyroscope, and also uh, how to use a wearable sensor like a smartphone. So for example, the one thing I want to ask, you have three axes. How to determine which is x, which is y, which is z, and how to calibrate um, the, the three acceleration signal, and also transmit the signal to a host computer. Today we will show you how to, I will show the use iPhone. Lee will show how to use Android phone. And also the third one is motion signal collection and processing. So maybe after today's class, you can start to use this one collection, get some data. For example, you made some fall, but this one I don't want you to do the real fall. You don't do fall. You just like put the uh, phone under the I mean put on the desk and push it down as a falling as falling. Don't do the real fall. This is very dangerous. Don't do it. You just like make it I mean artificial. You just put on the table and push it down and then generate a fall. And maybe Lee will show you how to generate the fall. You use artificial fall. You cannot use real fall, but you need to collect lots of data, the different fall, this way, that way, this way, that way, and then you determine maybe threshold. So normally the technique is like first you need to get rid of the DC component. You know the DC component is from the that means the gravity. The DC component is from the gravity. So why is from gravity? Because you know even you have no acceleration, you still have an input signal. The input actually is the gravity. So gravity is 1g. So even you have no signal. So in that case, the first is you need to get rid of 1g, and then you just measure the magnitude of the fall, and then you can estimate, give a threshold, and then over this threshold you said this is a fall, and then you set alarm, because this one will in real time communicate with MATLAB with your local computer, and you can generate alarm. This alarm may be just like words or things, and this is the expected outcomes. So basically, when you do the final presentation, you need to include all the procedure, general procedure, uh, and the outcome demonstrate comprehensive understanding for the AMU. So what's initial measurement unit? For example, how to determine x-axis, y-axis, z-axis, how to build a build a model. I mean, simple model. So for example, if you have a accelerometer, you have bias. The bias means like you have no input, you still have output. This is called bias. And then you have a scale factor. That means you give 1g, so the measurement should be 1g. But sometimes if the model is not good, they said it's 2g, and then you need to calibrate this uh, scalar. And also understand the basic knowledge of biomedical signal processing. This is a very basic. I mean, just like even you no need to go deep. Even this, you can see all of the procedure. You no need to know any signal processing. Uh, just like motion signal collection and processing. Processing may not go to signal processing. Just like simple processing. For example, get rid of some spark or things, and then the build algorithm for fault detection. This one you should be okay, and also display alarm on the computer. So that's the requirement. How about Lee? Hi Lee.
Yes.
I make you as a host. You want to co-host, or maybe I make you as a host, and then you start to. You are already host. I'm the co-host.
Okay. So should I start now?
Yeah, you start. Yeah. Maybe I stop sharing. Yeah.
All right. Good morning, everyone. So I'll talk about these three projects in a very simple way. There's no mathematics today. So first one is the fall detection. Uh, as you can see here, on the right of the screen, there's a Apple Watch. This is the latest version of Apple Watch. So here is the website of it. It adds a function that is fall detection. It means when you're falling down on the ground, it will ask you where you, if you need a hand or something. So, so this technology is very popular nowadays, and we will teach you how this works in a very simple way. I'll show you the device we made for the health monitoring. Well, it's a very simple prototype, and I'll show how it works on fall detections. Here is the MATLAB. My computer is quite slow. Just need some patience. So I'll show you how to generate the artificial fall, so it won't hurt you. So I put this device in a box and I fulfill it with some pivets. So if I throw it from here to the ground, and you can see there's a fall detected warning windows here. That means you the fall have been detected by your device and your algorithm. And the second one is the head movement identification. Steven,
Yeah, yeah.
should I go through it?
Yeah, go through the second. Maybe I introduce first. I give a little introduction. Uh, yeah. Can you see my screen?
No.
It's okay now?
Yeah.
Yeah. So this is mean fall detection, but the next one I think is rate estimation. So when you do exercise, that's the second one. Exercise monitoring. So basically, you put the MU and on the body, and when you do exercise monitoring, the one important thing is that you want to estimate what kinds of exercise you are doing, and then what kind of based on what kind of exercise. For example, you are running, or you are jumping, or you play basketball, or you are play badminton or tennis. So we need to judge what kind of exercise you are doing. This can use data analysis to tell and use classification. But for this project, I'm not ask you to do so hard things. I just like let you to estimate the exercise rate. So what's the rate you exercise? This is important because this is your exercise strength, and then we can estimate, approximately estimate how many energy you spend. For example, for the diabetes, for the you want to control your weight, you need to know how much you have cost your energy. So in that case, we estimate the energy you spend, and then the first thing is to estimate the rate your exercise. For this one, I will later I will show you based on the connection how to connect the hardware with how to connect the iPhone, and I will do the explanation how to estimate the rate. We can use actually the procedure again is like we basic skill how we use smartphone and learn the basic concept IMU is all the same, and learn data collection using a smartphone and biomedical signal processing. This one a little bit frequency analysis. Today I will do frequency analysis. That means I want to actually the rate is like frequency. It's how frequent you move. So we use a single just a very simple uh, uh, Fourier transform, FFT. I'm not sure you student already learn the signal learn the uh, Fourier analysis, Fourier transform, or Fourier series. And but this is very simple. I just teach you how to use the tools MATLAB to do that. And then you need to recognize different activity. This one is too hard. Maybe I not. This is it's optional, and I just want you to estimation the access rate uh, by a certain classification estimation algorithm. This algorithm is very uh, ad hoc. It's very special one. It's no one can teach you very general thing, general to how to generate. For example, you just use peak detection. You can detect the weight. When you get the peak, and you just calculate the distance between the peak, and then you know the rate, right? So this is a very you go to the website. They maybe have lots of algorithm you can use. This is permitted, but you need to set their paper. When you use their method, you need to set their paper. Even your presentation, you need to have a reference. You set their research result. And then this is outcome is like we what we want to is use MATLAB to classify different human activity by analyzing MU data. Maybe this one is the highest requirements. You no need to get this outcome, just like the rate, the access rate, the basic rate. Uh, okay, so that's my explanation for the second project. Maybe Lee, can you continue? Hi, Lee.
Yes, of course.
Okay, thank you.
And for the rate estimation, I'll show you a very simple feature here. This is from a sports watch, and you can see the yellow point and the red points here. This stands for the cadence of your photo step. So that means there's 150 around steps per minute. It's from a very new technology. That's not new technology, but a very popular one. Some of you may have seen this. It will analyze your activities and tell you how you to improve. Say sometimes my cadence is low, and sometimes my cadence is high. It will tell you your cadence is varying during the whole activities. And I'll show you how we do this. Also in MATLAB. So this is what I record this morning. I'll show you the video. So I type the little device on my foot, and I walk for several steps, and MATLAB can tell me how I walk. So you can see this. you can see the steps between. It's a little bit slow. You can see the steps here, and once you know the step, every step, and you know the time, so you know the cadence of your steps.
Yeah, that's too scary to student. This one is you need to use both accelerometer and the gyroscope.
Our project is not very. You don't need to do the visualizations, so it's quite simple. I'll show another.
So don't worry, this is just demonstration. We are not asking you to do this implementation.
Yes, yes. So for the peak detections, you just count the highest peak and the peak between in your how do I say? So
for the recorded data, you only need to detect the peak.
Times, you know the cadence of your steps. Yeah. Okay.
Yeah. So that's the second. That's the second project. Right? We discussed about the third one. The third project is called head movement detection. So head movement recognition using MU sensor embedded in a smartphone. So the general procedure, understand the basic MU data collection skill using a smartphone, and learn the basic concept of MU, and learn the data collection skill by a smartphone, and classify head movement by using MU sensor. So this is a little bit of classification technique, but it's very simple, maybe just like threshold detection. For example, you have you use maybe 3 accelerometer and 2 gyroscope, and then we can tell you are want to for example, you use the MU to control the wheelchair. For example, your hand have a problem, but your head is very healthy, and then you want to go ahead, you just nod your height, and then the wheelchair will understand what you want and then go ahead. If you want to go other way and then go, so they use accelerometer can detect because of the angle change. Because this part for this part the gravity is very useful. So you not need to remove the gravity, because the gravity give you an indication where is the gravity direction, and then you know your angle, your tilt angle. For example, this sometimes they call the pitch. Go know your pitch angle, and then if you want to find the rolling angle, rolling left, called the roll angle, roll ROLL, roll angle, and then you need to maybe use a gyroscope, because when you roll and then there's an exercise have a reading, the gyroscope can measure angular velocity. So this is for this project. You can see all the project is not hard, although looks complicated, but we only ask you to understand the basic functions, and also implement a very basic uh, classification of things. So even you don't need to have the classification knowledge, but I will teach you in a week. So Hai Li, could you continue with your discussion about the third one?
Yes, yes.
Okay.
Okay, for the head movement, there's also a very state-of-art technologies product people are currently use. So you see where this little microphone, it can control the wheelchair movement by using that. If they nod the hand, they yeah, tap your head, then it's going, and if you can see the screen. Yeah, there's something like that. So if you don't nod the hand, the wheelchair will go straight. Uh, if you roll your head, and the wheelchair will turn left or turn right. So how do the wheelchair knows your movement of your head? That's what we are doing in this project. So still, we use this little prototype to show you how we do this.
Because we have coronavirus, we cannot go to the lab. If you can go to the lab, we have enough the prototype. That's why we cannot provide you, but even we cannot send it to your home because this is illegal, because we don't have a, I mean, security issue. We have security issue we need to think about. So that's why we have to introduce using smartphone.
It takes some time. Yeah. You can see this little box here. If you tie it on your head and you moving around your head, and the computers know where your head is going. If you know the head, it's another direction. So this is called orientation. It's need a lot of mathematicals, but in our project we won't use that accurate algorithm. So we just calculate the inclination of your head. So it only requires a little bit trial cellular function knowledge. Yeah, that's it.
Yeah.
Ewan?
Yeah. Thank you. So we still have 1 hour to go. So the next step, I will continue with the rate estimation by use FFT called fast Fourier transform. We show you, and also I want to show you something about MATLAB, because our subject is MATLAB based. So I'm not sure. First, I send you a link. Have you read the how to draw 1D MATLAB figure? Uh, so you can stop me anytime if you want to start to talk. Just stop me anytime. Otherwise, I will continue my discussion. So first, I will show you how to connect the computer with the mobile phone, and then after we get the data, and then I will show you how to use FFT to analyze the data to see what's the highest frequency I can generate. Uh, you can try your one as well. We can competition. So you can generate the highest frequency. You swing your mobile phone to generate as fast as you can. I think what's the fast frequency you can generate. And in the future, if you measure some frequencies over that frequency, and then you can just neglect, just like filter it out, and that's noise, that's some error. Uh, so this is a very interesting task, and one of the group maybe can select that one. So before go ahead, so do you have a mobile phone with you? Smartphone? Have you downloaded the smartphone app and install in your smartphone? So if you have someone don't have Jason haven't but doesn't matter. Maybe other people, other group, other your group member will have. So I remember it's someone already have a Emilia maybe already installed. So I just like that's why I want to group a little bit adjust the group because I need to guarantee every group have at least one iPhone to collect the data because after the class you need to do some experiment to collect them data and you send it to your roommate your group mate and to finish the project. Uh, so now I just show you how to connect the things, how to install and how to use MATLAB to run it. So first you put your I think this project information here. I already in the week 8 I have a folder there and but I have put project information. I think is one is here is this one I put when you download, if you are using Android phone, you download this one for Android, and then you just click. Hello?
You didn't share your screen.
Oh, sorry, sorry. Yeah, apologize. So this is the one I download. I download, and here is the zipped file. For example, you want to use the Android phone, and then you select the first. If you use iPhone, you use the second. So you put into the folder here, and then you right click. For example, you use iPhone, and then you just like extract here, and then you will get something like this, and you have a uh, full documents. So the first document actually, if you open, so they tell you how to download the sensor app. But this one is a little bit it's $7. You need to cost $7. And then you based on after download that, and I already download, but unfortunately today my camera is not working. But it doesn't matter. This one is actually very simple. It's just like I show from here. So they have lots of setting you need to set. For example, the most important thing I think is you need to set the protocol, the IP, because they use TCP/IP for communication, and the important thing is the rate, because this sampling rate is very important. If the signal change very fast, you need to sample fast enough. So this is called Shannon sampling theory, or called Nyquist sampling theorem. So it's like your sampling rate should be at least 2 times fast than the highest frequency you want to measure. So for example, when we do exercise, I have a show, I have a do exercise, I never can reach to 10 hertz. I mean, just I can reach maybe to 7 hertz maximum, and that's why I select 20 hertz. But if you can, for you, you can reach to, for example, 30 hertz, and then you can reset the rate to 60 hertz. But the maximum is 100 hertz for this code. So this is an important thing you need to adjust. Other things, maybe you can on the you make a gyroscope, you use gyroscope, you use accelerometer signal, and then you need to change the. I will show you. Open the MATLAB here, so you can see where's this is the one I download. So this is the IP address. The IP address can be found here when you run this code. They will show you the IP address. For example, when I go this one, if I run, so first you need to change the folder. If you put some folder, you need to change it to the folder, or you can add it to the path. That means they will consider the simultaneously two folder. So they consider them as one folder. So I put like this way is also okay. So you can see they have nothing appear. That means I didn't connect this well. So I didn't connect this well. So there's nothing come. And then I need to stop it. Yeah. And then I need to setting well, and then start to recording. And this time I run again. So this is the main aim. It's just like a main function. You just have two options. One is you just push run, or you just like type the name called aim. It's a you need to capital letter for M. So you need to type MAIN, and then this one will run as well. So you can see that's I only recorded. I only draw 3 acceleration. Actually, you have other measurement as well. Hi Lee. Hi Lee.
Yes.
Did you include the gyroscope signal here, or is just ACC? Just
There's no gyroscope.
yeah. But we need to include the gyroscope signal because if some group doing hide movement detection.
For the get data get Apple data function, you can return a gyroscope function data.
Here, you can change someone
down to the OM. Yes, OM is gyroscope.
OM.
You have the gyroscope data.
Okay, so in that case, this one, right?
Yes.
Yeah, and then you can select to get, but here you already selected OM.
Yes.
So you have OM.
Data.
So which variables you get for this one? OM, yeah, OM. So I use OM here. So this is the OM data you get. So I find you have always the first one is too big. So I already have need to delete this one. But anyway, so this one is already last time I introduced MATLAB. You have all the variables available here. Anyone you want to look, you just double click. So this is acceleration. This is the gyroscope. You can have for example, the time information. How many times you have 1,000, and also you have a IP address. So IP address we already installed. Input already, and how many sample, and also some port information. This is T is the time, here. So I'm not sure how many students currently can use the phone. So I stop here and I go back to the main. So the main code. So don't worry, like we will reorganize the group and to make sure like every group have one at least one iPhone, one smartphone. Sorry, and then we go to we after we get all the information, and then we can do simple data analysis. For example, we use Fourier transform to analyze the data. So first is like we need to plot the data. So how to plot the data? I put some reading material. The video. For example, we want to plot the acceleration data. How to plot? First, we need to set up this how many data we collected. For example, the n is 1,000, and then we need to know what's the sampling frequency. Sampling frequency we already set is 20 hertz, and also we need to know the sampling rate. The sampling time. Sampling time is very simple. It's just like inverse of sampling rate. So it's like this is if 1 divided by 20 is 0.05, and also you have a delta t. Sometimes some people want to use delta t, but they are the same, just sampling time. Sometimes I use delta t, sometimes I use ts. This increment of time, and also this is how long you recorded. This if you have 1,000 data, you times the period, you get the overall, and then I reset the t again. So this is a t frame. So if I go this way, so you can see that the t. If I t, because t is a vector, raw vector. If I transpose, I put a dash here, it will be a row, a column vector. You will easy to look. So this is the one I generate the time. So this 25. So they totally have 25 25 seconds, because you measure it, your measurements is 1,000, and then you that's we totally measure the time. So it's and then you can calculate the f, because when you draw the frequency analysis, you need also have a frequency excess scalar. So in that case, we do like this. So f is from minus half fs. You know the half fs is called the Nyquist frequency. So in that case means like if you have sampling rate is, for example, is 20 hertz, you only can measure the frequency is less than 10 hertz. So the 10 hertz is half of the sampling frequency. This is called Nyquist frequency. I'm not sure how many students have learned signal theory. If you have learned signal theory, you maybe know that, but doesn't matter. Here it's just like you just remember it as that's it. That's very stressful, very intuitive. Like me, if you sampling quick, that means you sampling means like for example, you open your eyes to watch something, how frequent you are. If you observe airplane take off, if you open your eyes every second, and then it will be see that. But if you every hour or every 2 hours you open one times of your eyes, you cannot observe between the 2 hours what happened. So in that case, you need to fast enough. So this one is the frequency, sampling frequency. So you how fast you need, like if something change have a frequency, for example, it's 10 hertz. If you want to see it, you need at least 20 hertz, double the speed to observe. So this is you build the f. The f we can see what f looks like. So f. Also, I look at the raw vector. So it's something like you can see the maximum is nearly 10 hertz. You only can look at 10 hertz. So of course it can be negative. So sometimes you call the double side Fourier transform. You also have a negative side, right? And then I can continue to go, and I draw. This is I draw the FFT. So it's FFT first. FFT. When you do FFT, you want to do it is FFT shift. So this one, I may give this piece of code to the group if they want to do the rate detection. So and then the FFT, and then they use they draw the figure. So here is I want to discuss with you how to draw a figure. First, you need to draw your recorded data. So today is the thing I teach you this, and when you go home, you do lots of experiment, and then you draw draw the data. So in that case, we can go plot. First, this one is figure 1. So this define how many figures you want to draw. For example, we have a figure 2 as well. We have want to draw 2 figures, and then we need to for one figure you can draw sub figure. So if you want to draw, for example, in one figure you want to draw 2 figures, draw, for example, this 2 and 2, this is called two column, two rows and 2 columns. So you can draw 4 figures in the figure 1. So in that case, you can plot. So this is the first figure. So is 1 is the first figure, and then you plot. This is the UUA, this is the 1, because this one is we don't have the time access. They just assume the time is just like used for the index of your vector. So in that case, it's 1, 2, 3, 4, 5, 6 until to 1000 if you have 1000 data. And then we continue to roll to draw and see what happened. So they have figure 1. So they have 4 figure because you have 2. You want to draw 2 row and 2 column, right? And then you have draw the first one. So subplot the first one. So this have 1000 data, right? You didn't define the x, so they just like. But they also you use this one is very maybe you think very annoying, and then maybe we change it to dot point, and then maybe we can draw to here up to here again. So this is maybe a little bit better. So you can see this one is use dot line to draw this figure, and then you can change it to other things as well. So this is a pattern of the figure, and then you hold on because you want to plot another figure. So you can hold on, and then you draw another one. So the another one is like it's just like actually the same. If you know you not tell what kind of type you use, and then you draw this just draw the continuous line. So they just like if I go continue, and then you can see. So they draw they connect them again actually for the things. This is what we measured. So if you want to see the inside what looks like, you just like you click here, it's a plus, and then you can see anywhere you want to see. So this is the detail of the measurement. So you can see some part is the I'm swing the mobile phone. This is the frequency I can generate it. The highest, maybe the highest frequency I generated. So you can try yourself to see how fast it is. And then we can continue to draw. This is title. You want to know this is the input function called fn, and then you can put a title called fn, and then I go. You can see there will be title here. So this fn, this is a subtitle. This is for the first figure, and we also can draw the second one. Draw second one. Second one we said subplot 2 to this 2. So we can have 3, we can have 4. So we can go to 2, and then we plot. So this is a Fourier transform or a transformed one. I think UU is sorry, it's a shifted one, and then we do FFT is Y. So this is shifted one. We can see after shift what do they look like. But don't worry, this one I mean it's not hard. Like I will you can see this video as well. After plot this one, we hold on, and we plot UU. Actually, this one is just point, just the start point, and then I want to give the where I get the data, and then I connect all the point, use the plot UU. Hold on, and then I give a name called shifted fn. Just like when you do a Fourier transform, you normally shift use this command, and then you can see what I get. So this is the shifted one. So you can see they are actually the same record but shifted. Can you see how to shift? And this half move to the first half. They put this half. They shift at 500. So they shifted. This we call shifted fn. And then we do FFT. We draw the FFT. Actually, we already calculated FFT. We only need to draw it. So this is the third. This is the third figure. So we draw the third figure. So you can see third figure, I continue, I draw, this is the FFT value. So or you call it DFT, discrete time Fourier transform, and then you can see we have the third one. So this is the third one. So the third one you can see because we have very big DC component, this DC component. So this is a haven't shifted. This is a cannot read. We need to shift the DFT. We need to shift. So we continue go and plot the shifted value. So this is the shifted FT I draw here. So this is quite clear. So this is double sideband, right? But the bad thing is like this one is only have 1000. We didn't give the meaning of the x-axis. X-axis actually should be frequency. So in that case, I redraw. This is just give the. I want to show what's the shifted DFT. So this one actually they shift from 500. They move this side to here. So we construct the double side FFT. So are you okay? Can you still follow? Hi Lee, can you hear me? Hi Lee.
Yes, yes.
Yeah. If no one can hear me, I mean maybe my phone have problem. But this I maybe a little bit quick. But if you think too quick, and just let me stop. But this one not that important. This just tell you how to draw a 1D figure. So this one you can see you have a draw 4 figures in one big figure. So you have subplot. You use subplot. Good thing is you draw them together. You easy to compare them. So that's good thing. But I will go ahead and another continue because we want to also get good the second figure. So that we if you want to second figure, you put the figure bracket 2, and you can second figure, and then you continue to draw. Continue. Maybe I go this way. Continue the subplot, and then subplot the so this 2 1 2. That means have a 2 row, 1 column. So they have a totally have only 2 figure. So the first figure we just draw the time in the time because this one I give time uh, uh, information. So you remember we construct the t here time information, and if we want to access in the axis we have a calculated value. We need to put two things right before you just use UUA, and then your x-axis is just the index of the array. So you have a 1000 array, and then you get 1000 from 1 to 1000. But if you calibrate with time, you have different scale, and then you can, for example, we got I remember we got 0 to 25, right? In that case, we look at what we get. So it's not easy to move. Maybe I make it bigger. So this one is the one 25. So this is all the point, but I didn't connect them. I will connect them soon. So if I go this way, oh, cannot move. It's not convenient. But I go ahead like this, and then I plot. This plot is I just connect this all the point, and then I give the x label. So this time because I use seconds. This is the unit is second. I give the x label, and I also give the title. It's time domain ft is the time domain ft. So and in that case I continue to here, and then I give the title, and then now you can look at the figure. So you can the figure have a title is time domain ft, and also I connected them, connect all the point. You can see the connection of the point, and also I give the seconds is the is the unit, but we have a negative one because we have to do the shift as well. So now we look at continually to look at the code, and then I go ahead with the second subplot. The second subplot is use the draw the FFT, and this time I hold on as first as all the point again. So this is all the point, and then I continue. I connect them together, and then X level title. We finish. So we finish the drawing the. So this is the one we draw. So you can see what might have generated the things is mainly in a DC component is very big. Why DC component big? Because of your gravity. I didn't swing the very hard, but you can see this is in one axis. It's a x-axis. It's very high. Maybe I change axis. This DC component will become smaller because your DC components always the gravities go down to the earth. If I use other x-axis, because this is x-axis, I use y-axis, and then it will be better to see the other part. But we still can see all of my movements is concentrated around 4 hertz, 5 hertz part. So if I go here, you can see that means a DC component is too big. It's covered this part. So in that case, I change it to another axis. But actually, we want to see is this what's the exercise rate around here. So if you do the select the second assignment, maybe you just do whatever you can do. You generate the first one, and then you can get rid of if you filter get rid of this part DC component, and then you draw the spectrum and show your major spectrum, and then you do a low pass filter, cut rid of all the signal noise. Maybe here is a noise. It's not you generated signal. It's some noise. So you can low pass this part. Now I change to another signal. Maybe this signal, I mean, I randomly select is not good. So maybe I can even so you can analyze because this is a debug. I change it. I close all the debug because we finished our explanation. So I no need to debug separately. So we go to so this is actually sorry, this is the third value of acceleration. So that means z-axis. I put x-axis to see what happens. And x-axis maybe DC component will be smaller. So we go wrong. So the DC component is still big, but the most my movement is in this area. So it's in the nearly 5 hertz, sometimes 5 hertz, 4 hertz. So you can see this is symmetry. So this is called double side spectrum. They have a 0 hertz, -2 hertz, -5 hertz. But don't worry, don't look at this side. Only look at the positive side. And also, what that means? 5 hertz means 1 hertz means like 1 times you swing 1 times. 1 second you swing 1 times. If you have a 5 hertz, that means 1 second you can swing 5 times. That means my fast movement is 5 hertz. I just swing as fast as I can. I got 5 hertz, something around here. Now maybe this one is still not good. I change z-axis. Maybe I swing not hard enough. Maybe I swing another one if they is not good. I put 2. This is a y-axis. So y-axis still the DC component is big. So in that case, I need to regenerate one. Maybe I look at look at gyroscope. We put OM. OM is the gyroscope. So this is we first look at x-axis to see what happened. So x is 1. So this means we look at because OM. If we look at OM, what OM looks like? OM is a matrix, something like this. They have the size. You can see what OM looks like. How many we can look at the size. It says it's OM. So you can see how many row and how many column. We have 3 column. We have 1,000 row. So 1,000 row. So in that case, if we want to read the first row, first column is the x-axis, and then we can use this symbol. You can pick any from 2, for example, to 100, 199, and then they will only analyze this kind of signal. But if you want to analyze all, you no need to write anything. You just put it like this, and then it will analyze all the x-axis. So for gyroscope, you can see the DC component. I mean, the move frequency is all around 5, so they have no DC component. Why no DC component? Because this gyroscope not sensing about the gravity. So gravity have no influence. So their DC component is 0. So no DC component. So this is measured AC component. And I also can generate another. Maybe the time is not enough, so I just like stop here. This is I give you the little I mean some explanation. So go home. I think you can watch the video, and also I give you the 2 video. You can watch this one. You need to understand how to, when you collect data, how to draw the data to see whether your data is recorded valid data. If you don't know how to draw that, you cannot observe. So today I want you to understand how to draw 1D figure. So you can draw subplot and give the command. I mean, mark the command, mark the caption, mark the title, and also mark the x-axis, y-axis, the things. So so that's all for the rate estimation part. Do you have any problem? If you don't have problem, I will separate the room according someone. So Amelia, you have problem with the MATLAB, right? Yeah. In the second, but is that your mean you open your app correctly?
Yeah.
Maybe.
I downloaded the file from the Google Doc.
Maybe yeah. Maybe can you yeah, that's good time. How about other group? Maybe I share your window. Can you share your window? And
Yeah.
maybe I give you a. Can you share it?
Yeah. I think I need to be made a co-host.
Yeah, I make you a co-host. Lee, can you make Amelia as a co-host, because currently you are the host? Is that? Yeah. Hi, Emily.
Yeah.
You are the yeah, great.
So I've run it a few times. It seems to be having a problem with this bit up here, but this is the error that I'm getting.
That means you didn't install the toolbox. So when you install your MATLAB, yes, you remember there's very many toolbox to select.
Yeah.
So you didn't install the specific toolbox, means instrument control toolbox. So you just rerun your installation program, and it will ask you what you want to do. You just say you want to change the you want to install another toolbox.
Hi Lee. Hi Lee. This one is before I don't know that you need the instrumentation control toolbox. Maybe next time we need to say something about that. And also I have when I install, I have another problem is like if you use UTS computer, you have a firewall issue. So you need to be the administrator account to run it. So if any other person have a problem, probably my suggestion is like even Emily and you can try. I'm not sure the workspace does it works. You can use workspace. Lee, I'm not sure. Maybe not work as well.
I'll have a go. But yeah, I haven't tried it yet.
Maybe because this one is have a TCP/IP communication. Maybe also have the firewall issue with workspace. So maybe
Yeah,
the best way is to reinstall. You select the instrumentation control toolbox because when Lee, when you write this code, do you specifically use the instrumentation control, or is like
Yeah. So the TCP block is included in the instrument control toolbox.
okay? You cannot get around this requirement. No, maybe Emily, you try to install the instrumentation control toolbox.
Not yet, but I will.
Oh yeah. No worries. How about Sai? Maybe I think the next stage is we separate the group according to the previous statement. I think it's like this. My first. Maybe I go to the email.
So I just put a link about how to install a separate toolbox, and you can find the installation guide there.
Okay, great. Thank you.
All right.
So in my first email, I already hi Lee. Do you have my first email? And I
Yes.
give the group information, so we can because currently I only have 9 students, so some student may be job. Yeah, so we have 9 students. But don't worry, our you maybe think it's too complicated today, but actually the project is not complicated. Um, we maybe we just like based on this 9 students, if they have available here, we separate our room to 4 room. With are you the host, right?
Yes. So
Yeah.
4 room or
Yeah,
3
you
room? 4 room or 3 rooms?
4 rooms because I need a single room to discuss. I need adjust the grouping little bit
Okay.
to guarantee that every group have the uh, mobile phone.
And I will do it now.
Yeah, thank you.
So according to the list you sent me, right?
Yes, just like the first one. Maybe we have a 5 minutes rest, and then we start again. Let Lee to set up the room.
So Steven,
Yep.
I didn't see the file on SAI. I didn't see this student on the list.
We should have.
It might be under Pranitha.
Yeah, Panisa. Yeah.
Oh, Anita.
Yeah. Okay.
What's next?
Next we discuss. We separate for you put everyone in the room, right?
Yes.
So we will discuss individually with each room
Mm-hmm.
and to select projects. Let them to select projects.
Okay.
You put me in one room.
Which one do you want?
Maybe you let me to be the host, and I put you. I mean, I will be easily to go each room.
Okay.
Okay, thank you.
No. And maybe you can put me in some room or.
Yep. I put you in room 1 first.
Okay.
Yeah, and then you can move to other room.
Hi, Stephen.
Hi.
I got put in a breakout room all by myself. I think I'm supposed to be in breakout room 3.
Oh. You should. I put you in room 3, or you want?
Yeah. Yes, please. I got put in a room all by myself.
Oh. Okay. I put you in room 3.
Yeah, I'm in group 3.
You are currently in room 3. I'm not sure.
Yeah, I was all by myself, and my friend, she's in another room 3. Maybe there's 2. I don't know.
But your name is already there. You cannot go to room 3. Amelia, and you both come out, right?
Yeah, I was in a room all by myself.
Okay. Give me a second. I will make arrange. Because
Okay, thank